Hello YouTube. Today we're going to be working on the standard normal distribution, and we're just going to be talking about the basics so you can actually use this for your statistical analysis. We always want to start with the basics because if you don't have your basics down then you can't really move forward or advance, so that's why I'm kind of making this kind of intro video. So here we have a standard normal distribution, and the thing with standard normal distribution is that the mu is 0 and the standard deviation is 1. So I'm going to write that, I guess, somewhere here. Okay, so this curve is actually represented by this function here, and it looks really complicated. And to be honest, you probably will never have to use this, except for you might have, well, we'll talk about that later, but you pretty much won't need to use it because of the way it's been simplified for something called a standard normal distribution table. Now, don't freak out right now. This section right here is just, well, this section right here is just magnified here. I just duplicated it so you can kind of see where this is coming from, because depending on what table you use, these values will be different. So I just kind of either look to the left of that black line or to the right. They're the same thing. The right one to the right is zoomed in so you can see the data tables better. But what do those represent? Well, this z value, or this z-score, as it's called, pretty much tells you what percent of the area under the curve is shaded. So between here and here, you know, pretty much it's just showing the shaded regions here. And that'll be a percent, say where it was 0.33. then you know that area has you'd have a 33% chance probability of finding a data value within that area. Now we assume that this is symmetric, that's why it's standard. So that means this side would be 0.5, that's half of it, because the area under this curve is equal to 1. 1 meaning 100% chance, so 0.5 plus 0.33 would be, if we wanted to include all this here on this side too, so we're just excluding that, would be 0.83 or 83%, and that's kind of what we're working with here. A few things you want to notice about just the normal, about this formula, I guess I'll point out right now, is that as mu and or the mean and the standard deviation change, it could be wider or taller depending on the curve, things like that. And by the way, this is like any statistician's favorite thing. Like, even if it doesn't look like the standard normal distribution, they will try to make it and convert it into the standard normal distribution, which I'll have in another video. But for now, we're just going to get into some examples. Okay, so we'll explain how to use that. So the probability of getting negative 1.33 or between those two values, so negative 1.33 and 1.33. So a few things to note, that this value right here, exactly at the center, is 0. So, and we also, that means if we want to go with these two values, this would be negative 1.33, and this would be positive 1.33. Now, our table only tells us what the values are, what the probability value will be between here. So how to look up what the area is here, if you want to find out what it is, you just look at your table. So let's look on this side of the table over here. So this value represents the z, and we're going from negative 1.33 to positive 1.33. Since there's no negative values here, you just look at where there's a 1.3, and there it is right there. Now that only tells you the ones place and the tenths place. Now you're going to look for the hundredths place. So you go scan until you get 3, and you get 3 there, 0.03, excuse me. And then you see where those two values intersect, and that is this value right here, 0.4082. So what it means is that this area under here is 0.4084, or 82, excuse me, of the entire thing, which is 1. So if that's only up from here to here, that's this range here. But we also want the other side too, so you simply double it because this area over here is symmetrical, or symmetric, so you get the same value here, and there would be that line there, and your total area would be the area under this curve right here. and that's what we're looking for. So you simply double it, and that's your percent. Boom, done. Multiply by 100 and you get the exact percent. Okay, so another one. So z is greater than 1.64. Okay. So what that means is that we're looking for all the values that are larger than 1.64. Larger than 1.64 would fall under this range right here, and that'd be that area. So our table only gives us between this distance and this distance, so it would only be this area. But we can still use that number to our advantage. So let's look at 1.64. So we go back here and we go 1.6, which is right there, and 1.64 intersects here. So you got 0.4495. 0.4495. So we go and we know that this area here is 0.4495. But what do we also know? Due to symmetry, we also know that this area here is exactly 0.5, or 1/2 of the entire area, which is 1. So if we know that, then we know that the other half here combined is 0.50, or 1/2. So with that information, you can conclude that you can subtract 0.5 from 0.4495 to get the remaining area here, which would be 0.0505, or 5.05%. Now obviously the picture is not drawn to scale, but I just wanted to show that you know exactly what area we were looking for. Okay, so let's do another one. So the probability of z lies to the left of 0.67. What I just did is I translated that to math terms. So lies to the left means less than 0.67. So if we have that set up here, so what's that asking? Well, it's pretty much, like it says, everything to the left of 0.67, or everything that's less than that value. So we're looking for this entire area here. So how do we get that? Well, our z table only gives us, again, the value of the area that's shaded here. So we can still use that because we know that this area is 0.50, as I've said before. So you simply add 0.5 to the shaded region, which you can find in your table, and you got to figure out that value. So let's look for 0.67, 0.67. So you go down here to 0.6 and then 0.07, and you get 0.2486. 0.2486 is right here, 0.2486, and this is 0.50. So you add the two together, because 0.5 plus that would equal all the way up to this value here, and you would get 74.86%, and that would be your answer. So that means if you wanted to find all the data if you wanted to find about 75% of your data, you know your z value would have to be 0.67, or you can, that kind of question. Okay, so we got, now the probability of the absolute value of z is greater than 1.96. So this one's kind of interesting. Okay, so we're looking for the absolute value of z, and our z is 1.96. So that means we're trying to find what's greater than those values. So it's definitely going to be over here. That's what we're looking, that's larger than that value. But we also want to include the negative values over here that would be negative, but now they're absolute value. So we're looking at these kind of the data, or the values from the data that are more on the outskirts of the distribution. So how do you do that? Well, again, our table only tells us what's in here, right? So let's figure out what that is first, because that's given information. Again, the reason why I know that, because the table shows you. Sometimes you might have a table that fills up to this part, so you got to be careful what kind of table you're using, and at least know how to use it. So I like this table. So we'll look at 1.96, so 1.9, and we go to 0.06, 40.475. So 47.5% of the data lies there. Okay, so this also means there's also 0.4750 over there as well. So if we know that the sum of each side is 50, or 0.5, 50%, that means what is the shaded area? Well, it's simply the difference between 0.5 and 0.475. And that would be each one over here, and then you can add those two to get the values. So the difference is 0.025, and that is represented by these areas here. So the combined, if you add both of those up, you would get 0.05 or 5% of the data. And that concludes how to, utilize a standard normal distribution using z-values. Now, I'll make another video about how to convert to z-values, because this is it kind of just got cut, so I don't know where it did, but hope this helped, and I'm going to make another video on how to convert and actually use this in statistics to benefit you. Alright, so good luck and happy studying.